In this session, we're going to solve problems from our topic 5, which is probability. The problems are extracted from our textbook from Keller. Alright, the first two problems, you can consider them as warm-up. They are very straightforward. They refer to the basic knowledge that we got from probability. So what do we have here? This is problem 611. Shoppers can pay for their purchases either with cash, credit card, or debit card. Now, the owner of the shop, he determines, usually from past data, 60% they use credit card, 30% use cash, and the rest use debit card. So first question, determine the sample space for this experiment. All right, so remember what's an experiment. It's any process or an action that we take and we expect different outcomes, or we call them sometimes the events. And the sample space is simply the list of these events. So what do you think? Here we're talking about what's the event. It's the way or our method of payment. So how many methods of payment here we have? 3, so that's it. This is our sample space. Now, for easiness later in relating to the probabilities of these events, I want to denote these with a letter. So H for cash, C for credit card, and D for debit card. Part B, assign probabilities to the sample events. Again, I told you this is a warm-up, so it's very easy. In fact, the probabilities are given to us, right? You can see them in the given. Let me highlight them for you. So it was given to us that, here we go, 60% they use credit card and 30% they use cash and the remaining debit card. So this gives us the probabilities, of course. So probability of cash is 0.3 or 30%. Okay, credit card 60%, and of course what's remaining is 10%. We know that the sum of all probabilities is equal to 1. Which method did you use in part B? So what do you think? Remember we discussed 3 methods. We have the classic, where the events are equally likely to happen. And we have a subjective, and the third one, which is the most used one, is what? The relative frequency. So here we go. This will finish our first problem. Okay, problem 612. Here we are referring to the same data used in problem 611. It's about the payment method. So remember we had the cash, credit card, and debit card. Now the question is, what the probability that a customer does not use a credit card? What do you think? How do we answer this question? Remember we learned a very important probability rule, right? Called the complement rule. What's a complement rule? It says that the probability of a complement of an event is 1 minus probability of this event. So the event that we're referring to is credit card. And when we say does not, so that means this is the complement, right? So if the credit card is C, does not use, this is CC, remember? We denote that as the complement. So this will make the probability of that. In fact, this should be a superscript. I'm sorry about that. Okay, so it's 1 minus the probability of credit card or paying with credit card, which is 1 minus 0.6, so 0.4. Part B, what the probability that a customer pays in cash or with a credit card. So here we have a key word, which is or. Okay, and this should remind you of which rule? The union rule, which says that the probability of an event A or an event B to happen, what do? We sum up their probabilities. And of course, usually if they have an intersection, we subtract the intersection, but these two events are obviously exclusive. They do not have any intersection because you either pay with cash or with credit card. and that's what makes the probability of their union to be simply the sum of their probabilities, which will make the probability of paying with cash or credit card to be 90%. All right, in problem 617, we're given the joint probability table. Remember what's a joint probability? It shows us the probability that two events happen together. So here we have four events, A1, A2, B1, B2. So how do we read this table? Remember, okay, let me first get my highlighter. Okay, for example, what's that 0.2? 0.2, we can see that at the intersection of B2 and A1, which means this is the probability of B2 and A1 happening together. All right, this is what we mean by joint probability. So let's see what the question here. We need to find, all right, the question was there, calculate the marginal probabilities. So you remember how do we calculate the marginal probabilities? If we are given the joint probability table, all what we have to do is simply sum up the rows and sum up the columns, and this will give us the marginal probabilities. So here we go. Again, let's remember how do we read the margin probability. So what's that 0.7? You see that this comes from 0.4 plus 0.3, and this is the probability of B1, okay, regardless of what's happening with B1, whether it's A1 or A2. When we talk about the margin probability, that's it. This is all the events that or these are all the occurrences with B1. Okay, and the same we can also interpret the sum of the columns, right? So for example, this 0.6, what that was the sum of 0.4 plus 0.2, which gives us 0.6, and this is nothing but the probability of A1. So you see that from the margin probabilities, given the joint probability table, we can get then probability of these events. So P of A1 is 0.6, P of A2 is 0.4, P of B1 is 0.7, P of B2 is 0.3. Okay, problem 618 refer also to the given table from 617, which I put it here for you, okay, on the right hand side. So here we go. This is the table that we got from previous problem 617. And here, what do we have? This is a conditional probability, right? How do we read that? Probability of A1 given B1. And we have a formula for that, which is P of A1 and B1 over P of B1, right? So all what we have to do is to read these probabilities from the table. P of A1 and B1, this is the joint probability. So we go to the joint probability table and we simply read it. Here we go at the intersection, 0.4. So we put it here. And P of B1, this is what? Yes, this is the margin probability that we got in problem 617, which was the sum of this row, which is 0.7. And we get 0.57. B, determine P of A2 given B1. All right, P of A2 given B1. Again, the same principle. We go and find the intersection or their joint probability A2 and B1, which is 0.2. And sorry, P of A2 and B1. So I'm sorry, it's not this one. That's wrong. I'm talking about this one, P of A2 and B1. So that's 0.3, and this is what we put here. Divided again by P of B1, similar to this one, right? So it's 0.43. Now the question is, did our answers in part A and B sum to 1? Yes, we can see easily that they do sum to 1, 0.57 plus 0.43. Is it a coincidence? What do you think? No, in fact, it's not a coincidence because you see both probabilities, this one and this one, we are asking what the probability of A1 given B1 and the second one also given B1. And so in other words, we are saying if B1 happens, okay, in both questions, the first question, what's the probability of A1? Second, what's the probability of A2? And by looking at the joint probability table, we can see that with B1, we can also observe only A1 and A2. There's no A3, which means that given B1, so if we are in this condition, that's it. These are the only two events that may happen. And these are reflected in these two conditional probabilities, which then we should be sure that the sum of their probabilities is equal to 1 because we have listed all the possible events in case B1 has already happened. All right, so in problem 628, again, we're given that in certain store, they collected data about the purchase mode or purchase method. And in addition to that, they also attributed to each purchase method the amount of purchase. So I remember we learned that we present such data into cross tabulation like what we're seeing here. All right, so we're looking at two dimensions. Here we have the amount of bill, and here we have the method, okay, of payment. Okay, so let's read any one of these and interpret it. Okay, so what does it mean here? This is 18% of all the purchases are made using debit card, and the amount was between $20 and $100. Okay, this is how we read it. You know that, just to remind you. So part A, what proportion of purchases was paid by debit card? Debit card, so we're looking only at this part. And you know that regardless of the amount, these are all the observations. And remember, if we interpret probabilities as being a relative frequency, so we know that all what we have to do now is to sum up all these. And this is what I did here. So probability of paying using debit card, it's 4% plus 18% plus 14%, so that's 0.36 or 36%. Okay, now we continue with problem 628, and the question is find the probability that a credit card purchase was more than 100. So we know that it was a credit card, all right, purchase. So here we know that we are using a conditional probability. And the question is, given that the payment was credit card, what the probability that the purchase was more than 100. Okay, so we're looking here. So you know that we will be evaluating how many these represent from these, right? And this is what the conditional probability illustrates. So if you want to use the formula, it's probability that this and that, so we go to the joint probability, which is 0.23, divided by the credit card probability of paying with credit card, which is 0.47. How do we get that? This is the sum of these 0.03 plus 0.21 plus 0.23 will give us 0.47, and the answer is 0.49. And finally, determine the proportion of purchases made by credit card or by debit card. So this is a union, so which means that we sum up their probabilities. So we sum up debit card or credit card, which we get from the marginal probabilities, and when we sum them, we got 0.83.